Hi, welcome to Statistics. I know what you're thinking. Why do we have to know statistics? I don't think statistics. Stop whining, it's okay. Actually, statistics does play a big role in your everyday life, whether you know about it or not. I'm sure most jobs you aren't doing statistical analysis, but in many lines of work and many things you may face in your day-to-day life, statistics comes into play. For example, now it's coming around election time, polls are being done, who's leading, who wants Obama, who doesn't want Obama, who wants this guy, who wants that guy. Polls are an example of data analysis. You go to the local Fred Meyer. Why is that Fred Meyer located there? Well, statistical analysis is used to locate stores. For a lot of organizations do that. Assembly lines are set up using statistical analysis techniques. You have a training program at your job. Why do they have the training program? How do they know it's effective? Well, they use statistical analysis to figure that out. In medicine, a lot of evidence-based medicine, as it's called, involves statistical analysis. Why do we use drug A? How do we know it works? Why do we give heart attack patients aspirin? Why, when you go to the doctor, do they check your blood pressure and not the length of your nose hairs? Well, analysis has been done that says these are things we should check to ensure better health outcomes. The weatherman, he actually uses statistical analysis techniques to predict, often not so well, whether it's going to rain or snow or be sunny. So statistics actually plays a role in day-to-day life, whether we want it to or not. So how will we use statistics? Well, what we're going to do with statistics is, first off, we're going to get a basic understanding of what a statistical study is, why they're done, how they're done, and then what they mean after actual analysis is done. What do these results tell us? A lot of people in statistics say, oh, well, this proves that or this proves that. In statistics, we will never, ever, ever, ever prove anything. But what we will do is come up with evidence to show that something is or isn't what we think it might be. Basically, what statistics is using samples of information to make generalizations about a larger set of data. So, for example, if I wanted to do a study on the average height of community college students, I couldn't take every single community college student in the country, but I could take a sample and I could analyze that sample, and based on that sample I could make some generalizations about community college students at large. And that's what statistics is for. Make predictions about things, show trends, what seems to be happening. Another thing that's important for us is so when we read a statistical study, or when the doctor says, well, you should take 2 aspirin a day, or you should eat vegetables and fruits, this is why. It's studies that have shown that these things seem to be effective. When you look at a poll or at some table or some graph in the paper, what is it saying? What data have people collected that they're using to make certain statements? So it's important to get an idea of how statistics work, because certainly, as we'll see in the course, statistics can be used to mislead. And if you understand statistics, you know how to present data in such a way that it can tell a story you want to tell. You aren't lying with numbers, but you're telling some story that may or may not be what people think it should be. So what's this class going to entail? Well, there is math, obviously, but as an author of a statistics book once said, the intro statistics class is much more about critical thinking than it is mathematical calculation. We do we use formulas, we make calculations, we come up with answers, we find probabilities. But the important thing in statistics is using that result to make some statement. Okay, the probability of this happening is 82%. What does that mean? The probability of this occurring is 1 out of 275. What does that mean? We have certain data we've collected. We can say this about the data, that about the data. We can make generalizations. What do those generalizations mean? Based on those generalizations, how might we act? So while this is a math course, it's maybe a different kind of math course. We'll get exact answers. However, those answers can be interpreted in different ways, which typically in math classes, well, x equals 5, x equals -4/3, that means something. But in this class, we'll find out that x equals 0.27. What we think of that 0.27 may mean different things for different people, and we'll see that as we go along. But welcome to the class, and hope you learn a thing or two. Cheers.